Alright, hello again, and this is another one of our videos, probably a bit shorter than we've had recently. But this week I just wanted to basically talk a bit about something that I've had the idea, or understood as an idea for a while, but never heard a good word for. And it's a sort of well-known thing of people that it can be a lot easier to think about things if you've just got a good word to describe them with. I mean, a lot of the stuff I've been discussing about variable names and things throws back to that, and there is a concept of that in sort of linguistic things, which, if I'm recalling right, is called the Sapir-Whorf hypothesis, that you can only really think about things you've got a name for. And not really meaning that here, just that once you've got a name for something, it's a lot easier to conceptualize and it's a lot easier to spot without having to go into all the details. And that's kind of coming into what in programming terms are called patterns and anti-patterns, where what you want is a nice shorthand name for something. Anyway, I came across a really good shorthand name for a concept I'd seen a lot and thought it was worth talking about, and that is what's called Tramp Data. So let's imagine you're writing some code, you're a nice obedient type programmer, and you hear all over the internet and things that global variables are bad. So you think, okay, I will not use global variables in my programs, I'll take them out. But I do need this data to be accessible throughout my program, so I'll start passing it through my functions, or storing it in my classes. So you start passing things, classes or functions, it's all the same to us. Your function signatures or your class definitions start to grow. You notice that rather than passing several integers, you should start to use data storage classes that bin together shared, conceptual shared data, several items that relate to the same thing, so that your function interfaces don't get out of control. These classes start to grow and you start to end up with what's called God objects, where you've got an object whose purpose is just to contain everything, all of the data you thought you might need. Or you start to proliferate. You've just got dozens of these little classes that exist just to form a data set for passing between functions. And then it gets worse. You start to realize that some things are needed really deep in your code hierarchy. And all of your functions start to need to be given these objects. And then you go even further and you start to realize that a lot of your functions need these objects, but they don't do anything with them. Literally, the only reason they need them is to pass to something else deeper down the hierarchy. And the reason this is a problem is because this is indicating that your program really is relying on quite deeply shared data. This stuff really is used across your code. And there's a lot of solutions to this problem. None of them are easy. It's not a really easy thing. It's a fundamental design flaw or design challenge. But it's absolutely not the case that the solution is just to try and hide your globals in the form of objects that you pass to functions. And in terms of what the design problem, the design challenge is, well, probably most of the time what this is turning up is that there's a deep problem with your code, that you've got deep-seated interconnectedness. Your objects aren't independent and can't do their jobs independently of each other. You've not got a nice defined hierarchy. In particular, you've not got parts of your code that can operate independently. Your code is tightly bound. Parts are tightly bound together, as in they need to reach into each other and do things within each other as objects, or functions need to call each other. You have tight dependencies as opposed to what you want, which is as weak dependencies as possible, where different parts of the code touch each other, affect each other as little as possible. Your code is perhaps lacking modularity. You don't have you don't have nice, clear, defined seams, as in the seams on a garment, where your code can be pulled apart and parts of it considered separately rather than together. What else? Perhaps your code is relying too much on manipulating state, where it really needs to have more of a functional kind of idea. It needs to think about or work in terms of taking something and modifying it, but not keeping it as state, just applying the modifications, using it, throwing it away again, perhaps. In the sort of the problem here then is that code like this, while perhaps inevitable, and some problems really will end up like this even in the hands of a very skilled coder, this is fragile. This is difficult to maintain. You've got these deep connections. If you want to debug this part of the code, you might have to look through all the rest of it, and you might notice that what I'm saying here is pretty much mimicking the reason global variables are bad. It's all the same stuff. But what you've done by passing your globals around isn't get rid of them, you've just changed what they look like. And in particular, why is this a problem? Well, in scientific code, it's not uncommon that you might want to stop a problem and restart it at some later time. Supercomputers, for instance, can be unreliable. Perhaps you need to go home for the weekend and turn off your computer. You don't want to just have to run something from start to finish. Maybe you want to be able to spot when something goes wrong, stop the code, fix the problem, carry it on. You want restartability. You don't get that with things this deeply connected. The idea of trying to go through the code and reset it up to look like it did before becomes overwhelmingly difficult. In industrial terms, the equivalent to this is sort of, making code interrupt safe, or allowing for failover, where if one server goes down, a different one can pick up the load. If you imagine how a web page works, for instance, every time you get a page, any data to do with that has to be sent to the server and given back to you. The server can't be permanently running some process which is the history of how this person viewed my web page in general. So that's the problem. Basically, global state is a problem and a bad thing. It doesn't matter if it's represented as variables or not. And the thing I came across from a very well-respected C++ programmer was a quote on a Stack Overflow answer, which I'll put the link to in the description of this. It basically says, passing global data into every function, whether it needs it or not, imposes a great deal of overhead. This is known as Tramp data, often reflects a design error. If these things are truly global, then they're global, and pretending that they aren't in order to make your code more object-oriented is a design error. I've very slightly paraphrased that quote if you happen to follow the link and look it up. I've just expanded a couple of acronyms. However, it is not a word-for-word quote. Anyway, that's the thing. What you often, or what you kind of start by doing in this situation, is not getting rid of your globals. It's just turning them into this idea of Tramp data, which basically is alluding to the fact that this data passes through a lot of places in the code, but not in order to be used there. It's just passing through. The problem is, it is modifiable by all of the places it passes through, and there's nothing much you can do about that. If we're thinking C++, there's a few things, but they're all considered really, really bad form. Other languages similarly. You can say that things are constant. You can enforce that they be constant, but you can't let that turn off deeper down in the code where they need to be non-constant. So you're a bit stuck. And this is, well, I'll say it again, it's retaining globalness, because now all of these functions that have to pass this data through could modify it. And that's bad. And this is also a more general principle, that there are a lot of programming principles and ideas, and there's lots of things where something might be described as a really bad idea. If you are lucky enough to never have to implement something which is on some occasions described as a really bad idea, then, well, I already said lucky, but you should think yourself lucky. It's just not possible that there won't be some case where the best option is still a bad idea. And it might be that in some cases having this Tramp type data is the best solution because things are global, but at least this way you can keep it together, you can keep it visible, the functions make it clear that they've got it. In other cases, just don't worry, use a global variable, use it right, consider it right, be aware of what the downsides are and what you're opening yourself up to. But if you really have got something that represents global state of the program, that's okay. It might best be represented as global state of the program. You're not always going to be able to pick a good solution. Your challenge is of picking the best solution, or at least a good solution. Even if a good one happens to actually be bad, you can see the problem with words that starts to arise here. You need to select a solution which solves the problem. Hopefully, that will also be a solution with elegance, or clarity, or maintainability. Certainly you should try and get all of those sliders as high up as you possibly can, as much elegance as you can. It's just that, well, sometimes it's about as elegant as an elephant on roller skates. So there you go, Tramp data. Data which is always just passing through. Useful idea, but in general programming terms, a thing to avoid. So I think we'll be back next week. We're hoping to be back next week, and thanks for listening as always.